Okay, so we're going to look at simultaneous equations and how to solve them. Now, simultaneous equations, in this case, we've got two variables that we need to find, so that's a and b. And so if we have two unknowns, well, we'll need 2 bits of information. And that's what we have here. We've got equation 1 and equation 2. So 2 unknowns, so 2 bits of information. Now, what we've got is a plus 2b is equal to 5. Now that's represented by this red line over here. And then 3a plus 4b is equal to 11. That's the blue line just here. Now what we're doing when we're finding a and b, if we think about it in terms of graphic solution, is we're just finding this point here that the lines intersect. So we're finding the a and b value of where the lines intersect. But without graphing it, there's two main methods for solving this. We'll look at both. The first is substitution method. What we do here is we substitute one variable into the other equation. Now, when you have, so we've got kind of 4 sets here. When one of them has a coefficient of 1, substitution method can be a good choice. I'll show you why. So if we look at equation 1, what we can do is we can keep the a on the left-hand side, but take the 2b to the right-hand side. And then you can sub 3 into 2. So you replace the a with the 5 minus 2b from 3, and you've effectively gotten rid of the a. And now you've just got a linear equation with only one variable. So you just expand the brackets. So you get 15 minus 6b plus 4b is equal to 11, which means we'll get 15 minus 2b is equal to 11. Take the 15 to the other side. So you get minus 2b is equal to minus 4. And you divide by negative 2. So you get b is equal to positive 2. And then what you do now is you sub b is equal to 2 into one of your original equations. Actually, it can be any equation. So it can be 1, 2, or 3. So let's chuck it into 3. So we'll get a is equal to 5 minus 2b, which is 2, 2. So a is equal to 1. So you've got a is equal to 1 and b is equal to 2. Now if you scroll back up here to the where the lines intersect, you can see, well, on the a-axis it's equal to 1, and on the b-axis it's equal to 2. So this method works really well when one of the coefficients is equal to 1. Alright, so let's look at the elimination method now. The elimination method, as its name suggests, says we want to get rid of one of the variables. Whereas in the first one, we substituted one equation into the other equation. Now we're looking at getting rid of one of the variables. So what we do here is, well, the coefficient, we look at the coefficients. The coefficient's 1 here, 2 here, 3 here, 4 here. So it's not super clear what we'll do. But there's a number of different ways you can do this, but what I like to do is you can see, well, 2b and 4b. 1 is a multiple of the other. So 4b is 2 times 2b. So what I'm going to do is I'm going to multiply equation 1 by 2. And that'll give us, so multiply both sides by 2, remember? So you get 2a plus 4b is equal to 10. And this will give you your third equation. Right, and then what you can see now is that the 4b and the 4b are the same here. So now we're going to eliminate them. So let's do equation 3 minus equation 2. So we'll get 2a plus 4b on the left-hand side minus the left-hand side of equation 2. So this section here, and then it's equal to 10 minus the 11 here. And now we just expand the brackets, and you're going to see that these 4b's are going to cancel out. So we'll go 2a plus 4b minus 3a minus 4b is equal to minus 1. They'll cancel. So you get minus a is equal to minus 1, which means a is equal to 1. And then we do a similar sort of thing. We sub a is equal to 1 into any of the equations. I'm going to sub it into equation 1 now. So we'll get a plus 2b is equal to 5. Whoops. That's meant to be 1 because a is equal to 1. And then you move the 1 to the other side, so you get 2b is equal to 4, which means b is equal to 2. So same answers for both of them, different methods, and it just depends on the actual question they give you. And you could, third option, I suppose, is you could just solve it graphically if you go to very, very good eyesight. Hope this helps.